Sibanye is one of South Africa's major gold mining companies and a very large client to us. So the brief to winder controls from the mine was a capacity upgrade to the machine and a simultaneous modernizing of this machine. This was all necessary due to an upgrade in capacity which the mine was pursuing at the time, and for longevity of the machine for the future mine requirements. Bearing in mind that the first time this machine was put in, the underground haulage ways, etc. were being developed and were fine to move these big masses through, but since then they've been quite congested with pipes and cable racks and various other things, and we had to really play a role in getting this new equipment into an existing mine now while it's up and running. At Winder Controls, we call ourselves a systems integrator and a solutions provider. We're very flexible with high levels of technical skills on all three disciplines, being electrical, mechanical and hydraulic. And then in addition to that, we offer quite advanced 3D scanning methodologies which would help the mine get these large components underground. And this flexibility enabled us to really address the complexity of the mine's problems here by, first of all, designing equipment which could fit the old foundation layout, and secondly, be able to move it underground with this high-tech scanning and so on. The original machine was an 18-foot winder supplied by GHH from Germany, which was a part of the CMAG group after the buyout. So the whole concept was, while lifting the machine's capacity, to also modernize the machine, entirely changing its complete rotating mass. What we did to the machine was fundamentally change its clutch design to a modern 3-part external clutch. In order to match the duty, we needed to ensure that the drum barrel thicknesses and cheek plate thicknesses were correct for the upgraded masses. We needed to make sure the rope speeds were right. The drums themselves became slightly narrower with a change to disc brakes. We removed the old shoe brake system and installed a modern disc brake system with escort control. The most significant components on this machine were the drum shaft itself, which is a 37-ton single billet, and it's a long piece of equipment. So to sling this under the mine cages was a significant operation. It had to be slung down using the surface man winder. That exercise in itself required significant checking on the machine's duty cycle, its capacity to lower that load, and of course it's being lowered through the existing steelwork in the shaft, which is a very careful process. We had to look at ways of designing the equipment that it could be split up into small enough parts that would firstly be able to pass through the main mine shaft, which is 1,700 meters deep, and then along the 300 meters odd of haulage ways from the shaft station to the winder cavern. We had to look at designing the drums in quarters rather than in halves. The drum quarters are 18 tons each, and of course significant dimensionally. To do this, we had to employ designs of very specific lifting and slinging equipment. The rail bogies, which would later be used to transport the equipment underground, were attached and slung as part of the main lifts with each component. And then of course the 3D scanning was a major factor in allowing us to overlay all the designs onto a 3D scanned model of the whole haulage way into the cavern, and ensure that we could avoid any clashes with infrastructure, with the rock on the corners, etc. That all worked out really well in the end, but without this methodology it would have been a lot more of a trial and error situation, which risks the mine's downtime and infrastructural damage and so on. A key feature was fitting the old foundation of the winder with minimal modifications to civil work. It was very much a precise measuring operation, and the 3D scanning was used to get detailed drawings of the foundation layouts. So our ability to accurately measure and design around existing equipment, I think, was a key part of our relationship with the mine on this project. A typical winder production is about 18 months. In this case, we didn't have to do the new motors and new electrics, but from the time of order signing till final handover on site was about a 13-month process, which we're very pleased with. The mine had already scheduled their main production shutdown and changeover of this machinery for the December of that following year, and we had to achieve that. There was no option of moving that out. And the shutdown process itself took about 4 weeks over that December, and we got the machine up and running without hitches and commissioned on time for the January start of production. The changeover went well. We had the right crews on site, the right backup from the mine. Again, significant focus on safety and risk assessments. It really very much, as I said, a collaborative effort which paid off and allowed this to be a seamless experience.